In this video, we're going to look at finding the shortest distance between a point and a line. Let's take a look at this one then. We've got a line here, which has equation y equals negative 3x plus 4. We've got a point T over here with coordinates negative 1, negative 3. And we need to find the shortest distance between the point and the line. Now, in this video, we're going to do this question twice. Firstly, we're going to do the question using the diagram, but then secondly, we're going to see how we could do the same question if we weren't given the diagram. So let's get started using the diagram first of all. What we need to understand is that the shortest distance between a point and a line is always going to be the perpendicular distance. That is the distance that's at right angles to the line. Now, this line here has a gradient of negative 3. So any perpendicular line to this one will have a gradient of negative 1 over negative 3, and that means it will have a gradient of 1/3. Drawing a line with a gradient of 1/3 through t, we get something that looks like this. Notice these lines here are at right angles. The distance we're interested in is simply this bit here. This is the shortest possible distance from T to the red line. So let's just focus in on this bit here. We can find this distance or this length using Pythagoras. We've got a right angle triangle here. We can see that this length is 3 and this length is 1. So the length of the hypotenuse, that's the distance we're looking for, is simply going to be the square root of 3 squared plus 1 squared, and that gives us the square root of 10. And there is our answer. The shortest distance from T to this line is simply the square root of 10 units. Now, keep all of this in mind when we have another go at this question, but this time without the diagram. If we're going to do this without a diagram, we're going to have to use algebra to find the coordinates of this point here. This is the point where the original line intersects the perpendicular line through T. That means we first need to find the equation of this perpendicular line through T. So let's get into it. Here's the same question, but without a diagram. We can see that the equation of the line we're given has a gradient of negative 3. So we know that the perpendicular line must have a gradient of positive 1/3, as mentioned earlier in the video. So let's find the equation of that perpendicular line. That line with gradient of 1/3 that goes through point T. There are a couple of ways you can do this, but I'm going to use the formula y minus y1 equals m multiplied by x minus x1 using the information we've got. So we want y minus this y coordinate, so that's negative 3, equals the gradient we're looking for, which is 1/3, multiplied by x minus x1, which is negative 1. Simplifying a little bit, we get y plus 3 equals 1/3 x plus 1. If we expand the right-hand side here, we get 1/3 x plus 1/3. I can rewrite the 3 here as 9/3, and I'm going to do that because it will make life easier for me to subtract that from each side. So subtracting that 3 or 9/3 from each side, I will end up getting y equals 1/3 x minus 8/3. Now, the whole point of finding this equation is so that I can then use it to work out where this perpendicular line crosses the original line we were given. So we need to work out the point of intersection between those two lines. Notice here we've got two equations in the form y equals something. So if y equals negative 3x plus 4 and y equals 1/3 x minus 8/3, we can set these as equal to each other. Negative 3x plus 4 equals a third x minus 8 thirds. And we can now solve this equation. Now, I find fractions a little bit annoying, so I'm going to multiply both sides of this by 3. That will give me negative 9x plus 12 on the left-hand side, and it will give me x minus 8 on the right-hand side. Now I'm going to add 9x to both sides. That will give me just 12 on the left and 10x minus 8 on the right. And then I'm going to add 8 to both sides. That will give me 10x on the right and 20 on the left. And that means x is going to be 2. So the x coordinate of the point of intersection is going to be 2. To find the y coordinate, we simply need to substitute this into either one of these equations. I'm going to choose this first one because it just looks a bit easier to work with. So I'm going to get y equals negative 3 lots of x, so negative 3 lots of 2 plus 4. Negative 3 lots of 2 is negative 6, plus 4, that gives me negative 2. So x equals 2, y equals negative 2. That means the point of intersection is 2, negative 2. Now, if you skip back in the video, you will see that the point where that blue perpendicular line crossed the red line on the diagram was actually at 2, negative 2. Now, we're almost done. All we need to do is work out the distance between t and this point here. We can do this using Pythagoras just like before. Now the horizontal distance between the 2 points is going to be 2 minus negative 1, so that's 3. The vertical distance between the 2 points is going to be negative 2 minus negative 3, which is positive 1. And we can take those horizontal and vertical distances, square them and add them and find the square root, which is all you do when you're using Pythagoras' theorem. And that gives us the square root of 10, just like before. Notice, however, how much more work we have had to do without the diagram for this particular question. To find the distance between the 2 points in this question, we needed to know the coordinates of both of those points. Now, we got given the coordinates of t, that was negative 1, negative 3, but we didn't have the coordinates of the point on the line that was closest to t. So to work that out, we had to first find the gradient of the original line, that was negative 3. Then we used that to work out the gradient of the perpendicular line, which is positive 1/3. And then worked out the equation of the line with that gradient through t. The equation of the line with gradient of 1/3 through t was this here. Once we had that, we could find out where this line crossed the original line. And we found that that happened at 2, negative 2. And those were the extra set of coordinates we were looking for. Then we could simply use Pythagoras to find the distance between these 2 points. Well done to you if you've stuck with this video right to the end. There's quite a lot involved, as you've seen, but hopefully you've understood the main steps and that will help you deal with questions like this in the future.